While unpacking the 6-pound 2-drum rotary rock tumbler from Harbor Freight reveals two of what we're now going to call ball mill jars, rubber jars with metal caps, a ball mill base with a switch on it and a cord to plug it in, 5 replacement drive belts, and a user's manual. On the base there are 2 of these little swing out plastic standoffs that if you loosen the screws and then adjust them out so they're at 90 degrees to the base, those standoffs keep the jar from running too far either direction and rubbing against the base as it's turning. So it is important to loosen the screws on these standoffs as you adjust them, otherwise you can break them. So just swing them out 90 degrees and tighten the screw back up. So we'll only be using one of the jars at a time as we run our ball mill, because one jar loaded full of what we're going to load it with, media and material, will weigh 6 pounds, and that's what this unit's rated for. One of the little rubber ball mill jars comes all assembled like this. Removing the nut from the lid, and then the washer, and using the washer in this little crack between the outer cap and the rubber jar, using the washer in that little crack to pry that outer lid off makes it easier to remove that outer lid. We have the outer lid with the taper on its edge. Then we have the inner lid with the threaded stud coming up out of the middle of it, and that can be pulled out of the jar just by pulling up on the stud. And that inner lid is made up of an aluminum plate with the stud embedded in it and a rubber diaphragm that fits nicely around the edge of that aluminum plate. It can be a little tricky to get it on once it's removed. There's no real good reason to remove it. Some of these diaphragms come not completely seated real well on the aluminum disc. They'll come sort of bent over like that a little bit. So it's a good idea to stretch the diaphragm out. Make sure that it's real nicely seated on the aluminum disc for future use when the inner lid is put into the jar. Well, I've got my ball mill jar filled with media and material to be milled, and this is a way to properly close and seal one of these mill jars. The inner lid sits down on this recess inside the top of the jar. If I start one edge of that and sort of pry out a little bit on the edge of the rest of the jar, that'll pop down in there, the lid will. Then if I just open this up on one side and squeeze the jar just a little bit, that burps out any pressure that's in there, and I can see that that inner lid is in there nice and evenly, the same distance down all the way around. Then I just take the outer cap and push it down on there. When I do push it down on there, the taper on that outer cap sort of pushes in this upper edge of the jar, sort of crimping it inward around the inner lid, so the inner lid can't pop outward under pressure and abuse from the media as the jar is rolling and the material is milling. So I push this outer cap down all the way around. It's completely seated on this outer lip of the jar. Then I just put the washer on and screw the nut on until it's just snug, and I can feel it starting to snug up there, but I don't keep cranking down on it. That's pulling the inner lid toward the outer cap, and I don't want to pull them all together. It just puts some pressure on the inner lid and the outer cap and keeps the outer cap from moving outward at all. And then to really seal it completely, if I take a strip of masking tape and just put it on the jar, sort of splitting the difference where that joint between the jar and the outer cap is. And just crimp that tape on there. That's a nice bit of security insurance to keep that cap from popping off while the jar is milling. And then when the jar is done being milled, that tape just pops off there real easily. Well, now to remove the ventilated heat dissipating motor cover from this unit, I'm going to loosen and remove the 4 Phillips head screws that hold the cover onto the base of the unit. I'll set these aside someplace where I can keep track of them and not lose the parts. I'm also paying attention to how this all goes together so I can get it back together when I'm done with it. The 4 screws go through this top solid plate first, and then underneath the solid top plate is just sort of a ring plate. It has a big hole in the middle of it. This allows the air to be circulated through this compartment and up and out. Keeping air circulating through there as the motor is running will keep the motor nice and cool. And this ring plate has these 4 spacers, plastic black spacers on it. These can come apart if you sort of work at it, but they will stay on there if you're gentle enough with it. So I'll set that whole assembly aside. And then now, looking at the inside guts in this motor compartment, I've got a motor. The motor turns a small pulley that is also attached to a cooling fan. So as the motor is running, cooling air is being circulated around the motor, being blown on the motor and circulated around it. The small pulley is attached to this large black plastic pulley by a black rubber drive belt, and the unit came with 5 extra replacement drive belts. And then that large black pulley is attached to the motor's drive roller, which turns as the motor is running. And when there's a jar on the unit, the jar, which is being turned by the drive roller, turns the jar, and the jar turns this idler roller over here. And both the galvanized steel drive shaft roller and the idler roller are covered with clear plastic tubing. Well, now I want to install this larger diameter vinyl tubing over the original diameter vinyl tubing on the drive roller. First step in doing that is to remove this silver cap on the end of the drive roller by removing these 2 Phillips head screws, and I'll set those parts off to the side. Then I'll gently remove this spring clip with the spring clip pliers, being careful not to spread it and stretch it any more than necessary to just get it off the shaft. I like to use the needle nose pliers to snug the spring clips back up when I'm done removing them. Then I'll remove this little black plastic bushing, set it off to the side. Then swinging this around, I can remove the drive belt if I haven't removed it earlier. Loosen the Phillips head screw on the large plastic pulley and remove that pulley. And now I'll see that on the end, this end of the shaft of the drive roller, I've got another spring clip, a silver washer, and another black plastic bushing. Lifting the unit up so I can angle that roller down as much as possible to get a straight shot at the spring clip. I use the spring clip pliers to remove that spring clip. Set it off to the side. I've tightened that up in a little bit. Remove the silver washer, remove the black bushing, and then the whole roller can be removed. Lubricating the roller just a little bit with a little bit of spittle. We'll get that large tube able to slide over the small tube, just twisting it gently as I go. Can persuade it on there just a little bit. And now the large tubing is centered over the smaller original tubing. And I'm ready to reverse the steps of this. Lift this up, bring the shaft in on an angle, put on the black plastic bushing, put on the silver washer, put on the spring clip that's been tightened up. And when I'm putting these spring clips back on, I make sure that they do indeed spring right back into their slots, which can be a little tricky. You can sort of turn the spring clip around on the shaft a little bit, and then you'll feel it when it just pops right back into its slot, and it can't pop back off easily at all. Then I'll put this end of the shaft up into its hole, rotating this bushing till that little tip pops into its slot. I will put this black bushing back on. Make sure that other bushing's in the slot. Put this black bushing on. Make sure this spring clip has been snugged back up. Put this spring clip back on. Make sure that spring clip is popped back in its slot, rotating freely, and it doesn't come out easily at all. I'll put the metal cap back on with its two screws. This is like speed disassembly and reassembly of a rifle in the Army. I've taken this apart and put it back together a few times in order to memorize the steps and get them down pat. So there, that cap's back on. The roller is securely in place and rotating freely. I'll put the black large pulley back on, tightening its screw down against the flat on the shaft. Put the drive belt back on, put it around the small pulley, get it started on the large pulley. Rotate the large pulley until the belt goes on down around it. And now the drive belt's back on, and rotating the shaft has the large pulley, drive belt, and small pulley rotating fine, and the whole assembly is working just fine. Now for a test run of the ball mill with the new enlarged drive roller. I've plugged the unit in. I'm going to flip the switch on. And you can see how it's stalled with the ball jar on there. That happens sometimes. And just lifting the jar off, letting the roller get started, and then dropping the jar on gets it rolling. And we'll time that, see how fast it's rolling. And I'm going to bet it's somewhere between 85 and 90 revolutions per minute. You can see how it will gradually creep down to one end or the other, and then the stop here will keep it from moving any farther and rubbing against the metal parts of the mill. And now, before running the mill, for some last minute lubrication and adjustment of the mill base, I'll take a little 3-in-1 oil. Just put a little drop on the 4 points where the roller shafts enter their bushings. That will allow those to stay lubricated and wear the parts as little as possible. I'll lubricate those, every 10-20 hours worth of milling to keep the machine running well. The large pulley and the small pulley need to be aligned so their center lines line up and the drive belt runs nice and straight and doesn't wear unnecessarily. And that alignment is accomplished simply by loosening the screw on the large pulley and moving the large pulley in or out a little bit as necessary to sort of eyeball and line up those two pulleys. And I just tighten the screw on the large pulley again, making sure that screw is bearing on the flat of the roller shaft. I also just go ahead and verify that the screw that holds the small pulley on the motor shaft is good and snug. Now, the tensioning of the belt, just to make sure it's snug enough, is accomplished by loosening the 4 screws on the end of the unit. These screws go over and through the motor. Loosening these up a little bit allows the motor to be slid either direction. And I want to slide that motor over just a fuzz. Make sure the belt's good and tensioned, but I don't slide the motor over so far that the cooling fan hits the side of the unit. And that belt is good and tensioned. It's running straight between the pulleys, both top and bottom, which indicates a good tension on that belt. The motor's sitting in there nice and square, so I will re-tighten those screws. And then I'll just reinstall the metal cover over the motor to protect the electrical wiring and connections and the drive pulleys and drive belt while the unit's being run. Put that ring plate on there with the spacers on it. Put the top plate on there. Put the 4 screws in it. Tighten them up. And the unit will be ready for a mill run of chemicals or black powder. There are certainly chemicals and compositions to not ball mill. Flash powder, real sensitive compositions. I never ball mill any. None of those are ever ball milled, and I never ball mill anything with any metal in it. Typically, I just ball mill individual chemicals: potassium nitrate, barium nitrate, strontium nitrate, ammonium perchlorate, or I'll ball mill black powder composition carefully per all the safety guidelines. Well, there is the reinstalled top plate, and that ball is ready to roll. The length of a ball mill run, normally an optimal run would be somewhere between 2 hours and 4 hours for a batch of black powder. A batch of an individual chemical might be finely milled in 30 or 40 minutes. It's a good idea to use a digital electric timer to set the time for the mill run. And especially when you're milling a composition like black powder, you don't want to get near the mill while it's running. This will turn the mill off automatically at the end of the time that's set on it, whether it's 2, 3, or 4 hours. Good media in this ball mill and ball mill jar is a 1/2 inch lead ball media, either half-inch muzzle loading bullets, lead bullets, or a hardened lead media can be used. The lead bullets will wear some. I'll pick that up later. The lead bullets will wear some over time. This is a nice hardened media that's hardened both with an alloy metal and also with cold quenching after it's cast. This will virtually last forever. I've measured and weighed this media after hours and hours of milling, and it's not decreased any in weight or diameter. An optimal load in a jar like this is half full of the lead media. These jars are 4 inches deep from the inside of the inside lid down to the bottom. So I want the media to fill the jar about half full. 5 pounds of this half-inch diameter lead media fills the jar half full and is an optimum media load. As far as material in the ball mill jar for milling, an optimum amount of material in the jar is that which would fill the jar 1/4 full when there's no media in there after the chemical has been milled. So the jar is 4 inches deep. I want the chemical or the black powder composition or whatever to approximately fill the jar 1/4 full after it's been milled. This potassium nitrate has been milled. There's about 3 inches left in the jar above the material that's been milled, so that material is filling the jar 1 inch deep. Approximately 4 ounces of black powder composition will fill this jar 1/4 full. Approximately 6 ounces of an individual chemical like potassium nitrate or strontium nitrate will fill the jar 1/4 full. In terms of, let's mix these two together for a minute. Let's pretend this is the result of a ball mill run. Normally, naturally, wouldn't do this indoors. The way to separate the material from the media is to use a separation screen and a bucket. Carefully dump the contents of the jar into the separation screen, and just gently roll the media and chemical around until the material falls through the screen and only the media is left. There, I've got nice clean media again. I can just dump that right back into the jar. And then this can be dumped in its own separate container. Naturally, all other safety precautions, such as using the mill remotely away from people when you're ball milling black powder compositions, barricading the ball mill just in case there's explosions so you don't have lead balls flying everywhere. Those safety precautions are covered pretty completely in the ball milling resources that were cited earlier in this project.